guys, you are welcome to this channel. With this channel, we are going to talk about some basic, simple mathematics that you might not be understand. The basic things that will help us to understand in mathematics. As a matter of fact, mathematics has become a major problem to most of West African students. This channel is going to help you to become a mathematician, as a matter of fact. So if today is your first time of watching our video, you can subscribe to this channel and hit the notification bell. So for any updates, you go to get it. Then you move on. Please stay with this channel and learn hard so that mathematics will become familiar. As on the board, today we are going to do introduction in vector in the plane figure. Just the introduction. Vector is a quantity, it's not a quantity. So vector quantity is a quantity that has both magnitude and direction. It has both magnitude and direction. So the keywords here is magnitude and then direction. So let's try and then disintegrate these two terms, that is magnitude and direction. So let's first pick magnitude. When we talk of a magnitude, we talk of the movement of a body from a starting point to end point. That gives us a magnitude. So without the starting point and the end point, the thing cannot be called a magnitude. So magnitude has a starting point and where it is going to end. That's magnitude. Very simple. And then the direction is where the thing is facing, where the thing is moving, where the body is moving. When the body is moving to the left, that's its direction. When it's moving to the right, that's its direction. Sometimes we might use the compass. Moving to the north, that's its direction. To the south, its direction. Whichever that goes, that's the direction that it takes. So that is the meaning of that. And then we also have some examples of vector quantities. We have momentum over there, we have force, we have weight, we have acceleration, we have displacement, and so forth. So we are going to talk about some basic things in vectors. Vector is not anything different. So first, let's move to the notation of a vector. Notation of a vector is simply a term given to how we denote a vector. How do you denote a vector? That is the notation of a vector. The notation of a vector is very simple. So let's go to our board and let's do it. Alright, so assuming we have point A and the particle is moving from point A to another point B. And let the particle move. The particle starts from here and moves straight to this point with its direction. So this is the initial and this is the final. Since we can able to identify our initial and the final, it gives us our magnitude. And the direction that we were explaining in our definition is here. And this is the direction. So you can see the direction of this vector. So in notation, in vector notation, we denote it by the points that we have on our magnitude. And we have point A and B. And mind you, the particle started from A and moved to B. So we write the vector notation as vector A, B. That's how it goes. That's vector A, B. And then we bring our arrow. Please, this arrow is telling us that the particle started moving from point A and moved to B. That's why the arrow started from B. So that is the vector notation. Very clear. Alright. Let's further on. And then let's talk about position vectors. Position vectors are small letters printed in bold. They are denoted by small letters printed in bold. For example, letter A, B, C. I made a small letters. Small letter A, small letter B, small letter C. Any letter of your choice. Only if it is written in a smaller form. That will give us our position vector. It's very simple. So in handwriting, we underline small letters to represent position vector. Okay. So in your textbook, you may not have the underlined word or the letter. They will not underline the letter, but they will let it be bold. I hope you know bold. They will let it be bold so deep so that your concentration will fall down. But when we are writing it on our handwriting on the board in our books, we underline the position vector so that you're able to tell us this is that and that is that. And then from there, we move to the representation of vectors in standard basis form. And then normally we can able to represent our vector in two main forms. Two main forms. The first one that I can say is column or component form. The column or component form. When you say column, it comes like this. It comes like vertical, like the vertical form. Or we can also represent our vector in magnitude and bearing form. Magnitude and bearing form. That's how we can represent our vector. So let's first learn how we're able to represent it in column or component form. What's the column or component? Let's do it. So the component form of a vector. Now the component forms goes like this. Let me take my vector AB on the board. So when we have vector AB, and it is equal to good. So this is the component form, the column or component form. You can see it's column. Vertical. So this is one way of represent our vector, the component form. Then the component form, and then the point two is the magnitude and bearing form. The magnitude. So with the magnitude and then the bearing form, we may have it is a horizontal. We represent it in horizontal. For example, we have vector AB and moves maybe 48 kilogram 008 degrees. So this is an example of a magnitude and bearing form of representing a vector. So normally these are the two main ways of representing, and that's what we're going to use in our various and other videos. So make sure you continue to follow and learn important things. All right. So that is that of the component form. So this is the column or component form of representing a vector, and then this is the magnitude and then the bearing form of representing a vector. So let's quickly move to unit vector. So we said a unit vector is one which has one magnitude. It has one magnitude and it is indicated by putting a circumflex or a hat, something like a hat, to represent the unit vector. So the unit vector unit vector, you see that it has a magnitude of 1 and it is denoted by putting a hat or circumflex on top of the letter. For example, if it is A, the unit vector of A becomes A circumflex, or someone will say A hat. So that is very simple. And then we can consider the Cartesian plane of coordinates. We can use this Cartesian plane and also to estimate. So in Cartesian plane, assuming a particle is here, this is y-axis, this is x-axis. So we have our xi here, then g. Or because when we are representing the vector in Cartesian plane, the s component, the vector is compared to the Cartesian plane of coordinates, that is x and y. Okay, so x is on top and y is on down. So when we are represented by a vector using the unit vector, we denote I by x, that shows us the unit vector, and then y by letter j, that's small letter. So assuming we have a body started from this point and move to this. So we're having our xi here, then this is that. So when we want to write our unit vector from this, our unit vector is going to be, let me say A hat is going to be xi plus y. So this is a unit vector using the Cartesian plane. I think this one is very simple. So make sure you practice by using to solve examples. So, and then we can also tell you, as we have a vector of vector AB of 2 minus 3. So when you want to write this in unit vector form, it becomes 2i, because the 2 is the x component and the minus 3 is the y component. And don't forget, I is always on the x. So that's what you have to do. Then plus minus, because this is negative, negative 3j. So this is a unit vector. If you don't want to write it in this way, or in case of an exam, they ask you to represent it in a unit vector form, and then the exact way for you to do that. It's not that fast. So that is how the things goes. Good. And then we are going to talk about the last introduction. That is the inverse or negative of a vector. Inverse or negative. When you say inverse, then it's like it is turned upside down. It goes into its inverse to the opposite. Negative. If it is not positive, it is negative. So when in case of you see inverse, in the absence of the negative, they are the same thing. So let's look at the inverse of a vector. So that is the inverse of a vector. As inverse of a vector. And this is the latter part of the introduction to vector in the plane. Inverse of a vector. So when we talk of inverse, as I already said, opposite of it. Opposite of it. Okay? Opposite of positive, negative. So assuming we have our vector AP, and then the inverse of AB is equal to BA. And this is equal to negative AB. So that is the inverse. So if vector AB, if we have vector AB to be equal to x, y, like this, in the component. So the inverse or the negative of the vector is going to be negative AB vector is equal to BA vector. That will be giving you minus x minus. So very simple. Very simple. So when you have a component, for example, we have a component of negative 2, 3, and it asks you to find the inverse of that, it's going to be 2 negative. Just putting the negation over there. Then. So guys, you end here, then look for the rest. In our next video, we are going to do more examples, then the rest of important things concerning vector. Please stick to your mathematics, stick to our channel, and follow any video that will come in, and then we'll see you.